Assalamualaikum warahmatullahi wabarakatuh and salam UiTM di hatiku. As for today, our group will going to present about development of sustainable product.
Human life is often linked to civil engineering. So, for the definition of sustainable construction is a living concept that varies depending on the need of the people. Sustainable development, also called green building or environmentally friendly development, is not a particular style, technique or practice. For the introduction, life cycle assessment of precast concrete unit is precasting is true to be an environmentally friendly method. There hasn't been any research into the life cycle performance of precast concrete units. The building industry consumes a lot of energy and emits a lot of pollution. Thus, sustainable development has gotten a lot of attention in recent years. LCA or life cycle assessment is a method for evaluating a product environmental performance over its entire or partial life cycle. Through extensive LCA case studies of two precast units, namely free-kit and bathroom, this work attempts to close the information gap. Material development for sustainable precast concrete block pavement. For the introduction, the most prevalent roadway and highway building material are Portland cement and concrete, PCC, and half concrete AC, both of which are better suited to continuous slab pavement. Both materials are difficult to repair and their lifetime is heavily depend on building quality and technique. In situ, large diameter slab-based procedure with Portland cement concrete or hot mix half-wave concrete are used to extensively in traditional modes of roadway and highway pavement construction. The usage of block pavement is an alternative pavement technique. PCB, which is concrete block pavement, are easily replaced, resulting in less loss of materials and building time. For the objective, first, maximize the use of concept green sustainable development in construction to achieve by the use of civil engineering material in the design, construction, use and demolition processes, and resulting in veritable green project that contributes to the long-term development of our country and the entire human society. For the Journal A, this we shall intend to fill a knowledge gap by conducting a full life cycle assessment (LCA) for two precast elements, the facade and the bathroom. For the Journal B, improve the quality of block pavement by using PCC Portland cement concrete, a block with waste tire crown rubber in place of river sand as fine aggregate. For the journal that we use, first is Journal A, which is life cycle assessment of precast concrete unit, and Journal B, material development for a sustainable precast concrete block pavement. For the methodology of our first journal, first, scope of the study. The materials such as cement, sand, aggregate, and admixture are brought to the precast yard from the manufacturing plants. The batching plant, which is usually located within the precast yard, is where these raw materials are mixed. Reformers are cut to the size and then installed according to the plan. After that, concrete is poured into the steel mold to form the precast part, and curing, usually with water, is required to maintain the concrete quality. To check the strength, control cubes are manufactured from which the demolding time can be estimated. The precast unit is then delivered to the construction site. Next is life cycle inventory. A field survey was done to investigate precast manufacturing processes and collect data for the construction of an LCA model. The precast facade material proportions are generally consistent with the bathroom, and tiles are applied to the bathroom at the precast yard. Last method, life cycle impact assessment. Provide analysis at both the midpoint and endpoint level. It comprises characterization and normalization in the midpoint version and additional damage assessment, weighting, and a single score in the endpoint version. For our second journal, first, material. The properties of cement were determined and the finding of the test was summarized. The original fine aggregate was river sand. As coarse aggregate, crushed granite stone with a maximum size of 20 mm, the specific gravity of 2.63, and the fineness modulus of 2.7 were employed. With tire yielded crown rubber particle with a specific gravity of 0.689 after passing through a screen size of 4.75 mm. For the second method, mixed proportion. UNI paver for compressive and flexural strength test 50 mm thick paving block were fabricated at a local plant. Cylinder with a diameter of 100 mm and a height of 300 mm were cast to determine the static strength and modeling parameters. The control was M20 grade concrete with a cement fine aggregate and coarse aggregate ratio and water cement ratio. And lastly, test method. Waste tire fine are blended with varied percentages of fine aggregate in PCC blocks. The compressive strength, flexural strength, static modulus of elastic, the end impact energy of the block were then measured. The finding of comparison between the crown rubber coated concrete and regular concrete without it.
Discussion Journal 1. Based on the midpoint results, the carbon emission and energy consumption to produce one facade is more larger than producing bathroom. It is noted that the impacts on climate change, human toxicity, ionization radiation, metal depletion, and fossil depletion are significantly larger than the other categories. Next, a contribution analysis of one precast facade and breakthrough shows the results are similar except for a more significant impact for tile and less from aluminium. This can be explained as a larger proportion of tile and smaller amount of aluminium can be detected for the precast bathroom. Compared to facades, transportation accounts for a slightly larger impact, which is primarily due to the transportation of ceramic tiles. The endpoint results of the three damage categories and the single total scores. The value of the total score is the aggregation of all damage results. Human health is the most contributive damage category to the finance call. On the other hand, the damage to ecosystem results from eutrophication and ecotoxicity is less significant. The damage to resources is also obvious as a result of the use of fossil fuel and metal. The results indicate that the most significant impact of precast units is arising from raw materials rather than transportation and in-plant process. To improve the environmental performance, therefore, necessitates an efficient adoption of materials by recycling or reusing the waste materials such as steel, reinforcing bar, and aluminium. Sensitivity analysis has been carried out to calculate the total score of precast bathroom with the assumption of reinforcement bars are made of recycled material. With that, the total score can be effectively reduced. Another way to reduce the influence of raw material is to replace cement with cementitious materials. By substituting porous cement by blaster furnace-like cement, the total score of precast bathroom can be decreased. Transportation and in-plant processes which have rather limited impact on the total performance and resulting in a difference between traditional in-situ and precast concrete. The environmental benefit of precast concrete could be more obvious in the construction stage where the wastage is reduced despite further investigations are needed to verify this observation.
My name is Noor Erdina Nasuha binti Fardil Atrash. We will continue our presentation with discussion of block pavement. The diagram shows the experimental and actual value of a block pavement that respond in flexural and joint interlocking mechanism after experiencing some load. The block system provides a uniform response that gives the meaning of greater inflexural strength. It is also allowed the block separation at the maximum load. The stronger reading can be achieved by using rubberized concrete block, RCB. So what is RCB? RCB is a mix of conventional concrete with waste diaphragm that creating rubberized block pavement. This type of block pavement is high in flexural strength, depends on the quantity of the waste diaphragm inside it. Based on the studies, the flexural response of the loaded block may lie opposite to the formation of the joint. This will result the joints to reduce its stress. This mechanism is missing in continuous slab pavements. It then proves the advantage of using block pavements in roadway loading. Some of the way to improve the impact resistance of pavement blocks is to place the black toppings on block pavements. This trick has also been applied to airplane runways, which can also be considered for highway and roadway applications. Study shows that waste diaphragm rubber can help to improve the workability of the rubberized concrete in terms of handling, placing, and finishing wet concrete. The increasing of rubber content will reduce the compressive strength, but will increase the flexural strength. This is the application of the tension strain hardening. If we combine the flexural hardening and joint interlocking, it will result the rubberized concrete block pavement as a great roadway pavement system.
The next point is conclusion. Okay, so this is the first conclusion of the first unit, which is life cycle assessment of precast concrete unit. Okay, so the objective is successful, which is a success to filling the knowledge gaps for precast elements used which are affected and better by conducting a full life cycle assessment (LCA). Okay, so the progress is so great as it's collect all significant data to perform a good results. However, there are small weaknesses in the results when the damage in human health, which contribute as the most important category, is higher than other categories, such as resources and ecosystems. But overall, the objective is achieved and it is good research. Okay, the next one is, okay, so this is the conclusion for the second journal, which is material development for sustainable precast concrete block pavement. Okay, so this objective of this research is also achieved and successful, as it is showing that the quality of block pavement is improved by using Portland cement concrete blocks with waste diaphragm rubber in place of river sand as fine aggregate. Okay, so the objective is also achieved since it's proved that it's increased the strong values, improve the workability and easy to handling compared to normal concrete. However, they also have a small weaknesses, which is the results. The research were the flexural strength starts to decrease when the percentage of strong rubber is over 15%. Recommendation. Okay, so the recommendation of the first unit is to improve the quality of precast concrete category in order to increase the damage of stated category in data excluding for human error. Therefore, it can be improved in the further works by stating the solution or at least how to decrease the damage in each category. It could be interesting to test precast concrete combining with other materials that could help in reducing damage error in appliance construction. So the next thing for the second journal, which is it has a small gas that still under unsolved, which is explanation based on the tension strain hardening, which is related to the flexural strength as well. It can be improved in the next further works by demonstrating more on the global behaviors of a block pavement system with a joint response monitoring. Therefore, we can find other material that can also work as good as from rubber or a combination of any other materials with from rubber for high quality of a concrete use in construction. So this is our reference use in this project. I guess that's all. Thank you.